Uh, at equilibrium, the concentration of uh, N2 is 3 into 10 to the power minus 3 mole per liter. O2 is 4.2 into 10 to the power minus 3 mole per liter. And NO is 2.6 into 10 to the power minus 3 mole per liter in a sealed vessel at 800 Kelvin. What will be the Kc for the reactions N2 gas plus O2 gas that gives twice NO gas? That is what we want to study here, my dear students. So to understand it well, let us first write the equilibrium constant Kc for this. For this reaction, as this NO is having a stoichiometric coefficient 2, so NO to the power 2 divided by N2 multiplied by the concentration of O2, because N2 and O2 are the reactants, and that is, let us put the value of NO, that is 2.8 into 10 to the power minus 3 to the power 2, and the concentration of N2 is 3 into 10 to the power minus 3, whereas the concentration of O2 is 4.2 into 10 to the power minus 3. So by doing this simplification, minus 3 into 2, that gives us minus 6. This minus 3 plus minus 3 will also gives us minus 6. And my dear students, by doing this simple, for 2.8, we can write 1.4 multiplied by 2. This 2.8 we write in the same way. This 3 and this 4.2 is 1.4 multiplied by 3. So by cancelling this 1.4 and 1.4 and um, 3 with 0.8, we can find 5.6 divided by 9, which is having 0.622. Now you can see that I have written here there is no unit, because in upper side that is a mole per liter square and divided by mole per liter into mole per milliliter. So due to this reason, there is no unit for this answer. Now let's move forward and understand the next question. The equilibrium constant expression for the gas reaction is this: Kc NH3 to the power 4 into O2 to the power 5 divided by NO to the power 4 and H2O to the power 6. Now we want to find out, we need to write the expression for the reaction. So what kind of reaction it could be? So we are well aware that this part is our product, this part is reactant, and these are the stoichiometric coefficients. So we can easily write that the reaction should be N4NO plus 6H2O, that gives 4NH3 plus 5O2. So the same way I have written here that 4NO plus 6H2O, that gives 4NH3 plus 5O2. Now my dear students, we want to study about the type of equilibria, and the first type of equilibrium is a homogeneous equilibrium. So in a homogeneous system, all the reactants and products are in the same phase. For example, you can see that in this equilibrium, when it is established, we have nitrogen, hydrogen and 2NH3. All these three are in the gaseous phase. So the reactants and products are in the homogeneous phase. Similarly, for these reactions, if you look at CH3 COO C2H5 aqueous plus H2O liquid, that gives CH3 COO aqueous plus C2H5OH aqueous. So here all these are there in their liquid phase, or you can say that they are in the aqueous phase, because H2O liquid is actually the solution of H2O into the water. So this is how we can say that this is even the homogeneous equilibrium, and as this is the homogeneous equilibrium, my dear students, we can easily understand that those equilibrium where all the reactants and products are in the same phase, such equilibrium is known as the homogeneous equilibrium. One more example: Fe plus 3 aqueous plus SCN minus aqueous, that gives FeSCN plus 2 aqueous. This is even a homogeneous equilibrium. All the reactants and products are in the same phase. Such a situation is known as the homogeneous equilibrium. Now let's move and understand the next part, that is equilibrium constant in the gaseous system. So for gaseous system, my dear students, we can understand the equilibrium constants. Let us understand how. For gases, concentration is expressed in the terms of the partial pressure. So for the reaction A mole of A plus B mole of B, that gives C mole of C plus D mole of D, we can write equilibrium constant Kp. So Kp is equal to Pc to the power C. See, I'm talking about this. P pressure of the C to the power C, stoichiometric coefficient. Same way P capital D to the power D. Same way PA to the power small a, and P capital B to the power small b. This is how we represent the equilibrium constant, and this equilibrium constant, instead of Kc, we call it Kp. But remember, we represent Kp only when there is at least one gaseous reactant or product present at the equilibrium. Pc represents the partial pressure of C, Pd represents the partial pressure of D, Pa represents the partial pressure of A, and Pb represents the partial pressure of B. Remember, A and B are the reactants while C and D are the products. In equilibrium mixture, at equilibrium and constant temperature, A, B, C, D are the stoichiometric coefficient of capital A, capital B, capital C, and capital D respectively in the balanced chemical equation. So this is how, my dear students, we understand the equilibrium constant for gases, which is known as Kp. Now for the reaction, if we have A mole of A aqueous plus B mole of B aqueous, that gives C mole of C aqueous plus D mole of D aqueous. Kc we write concentration of C to the power C, concentration of D to the power D, concentration of A to the power A, and concentration of B to the power B. For gases, especially when we have the gas which behaves as an ideal gas, PV is equal to nRT, and therefore P is equal to N by VRT. Now what is L? L represents the number of moles of gases. V represents the volume in liter, and therefore N by V we can write mole per liter. That is what it is, molarity. This molarity N by V, this, if N by V is mole per liter, that is molar concentration. So it represents, N by V actually represents the concentration. And that is why instead of N by V, we will write C, and P is equal to CRT. Now C is nothing but your mole per liter concentration, and therefore as P is equal to CRT, PA is equal to CART, that is the concentration of A into RT. PB is equal to CBRT, that is concentration of B into RT. PC is equal to CCRT, that is the concentration of C into RT. PD is equal to CDRT, that is the concentration of D into RT. So if we write Kp for this, we can write Pc to the power C, Pd to the power D, Pa to the power A, and Pb to the power B. But we know that Pc is equal to CCRT to the power C because we have power C. Same way for Pd we can write CDRT to the power D. For Pa we can write CRT to the power A, and for Pb we can write CBRT to the power B. And therefore your Kp is equal to concentration of CRT to the power C, concentration of DRT to the power D, concentration of ART to the power A, and concentration of BRT to the power B. This is what we can easily understand, my dear students. So ultimately, dear students, we can easily understand that Kp is equal to your C to the power C, RT to the power C, D to the power D, and RT to the power D, A to the power A, and RT to the power A, B to the power B, and RT to the power B. That ultimately leads us to the C to the power, concentration of C to the power C, concentration of D to the power D, concentration of A to the power A, and concentration of B to the power B. Here we have in the numerator RT to the power C and RT to the power D, whereas into the denominator RT to the power A and RT to the power B. For this particular expression, we can write Kc. So Kc is equal to concentration of Kc is equal to this expression, concentration of C to the power C, concentration of D to the power D divided by concentration of A to the power A and concentration of B to the power B. Now we know that if we have x to the power m and x to the power n, then we can write x to the power m plus n. So here we can write RT to the power C and RT to the power D, that is RT to the power C plus D. Same way in the denominator RT to the power A plus B. And therefore, if we are even aware that if x raised to m divided by x raised to n, that is equal to x raised to m minus n. So we can easily write RT to the power C plus D minus A plus B. But my dear students, we have already studied that the number of gaseous moles of products minus number of gaseous moles of reactants. This is your NP and this is your NR. So it is NP minus NR, which is nothing but your delta N gas. Now for the reaction A mole of A plus B mole of B, that gives C mole of C plus D mole of D. C plus D minus A plus B is equal to number of gaseous moles of products minus number of gaseous moles of reactants, that is delta N gas, and therefore we can write Kp is equal to Kc into RT to the power delta N gas. This is a very important equation, my dear students. Please learn to derive this equation well. It is necessary that while calculating the value of Kp, pressure should be expressed in bar as a saturated solution is 1 bar. Now this is even a very important point. Whenever you are calculating the value of Kp, please remember, my dear students, that we will always have the value of pressure in the unit bar. So for just the conversion, my dear students, please remember that R is equal to 8.314 joule. So that is what it is, not of our use, but R is equal to 0.082 and the unit is liter into atmosphere per mole per Kelvin. Now this is the unit for R. Now we want to write this unit of R into R is equal to 0.082 liter into atmosphere per mole per Kelvin. But we are well aware that this 1 atmosphere is equal to 1.01325 bar. So we can multiply this value 0.082 multiplied by 1.01325, and finally we get 0.083. Please remember, and the unit will be liter into bar per mole per Kelvin. So please remember that whenever we will be calculating Kp, we will be using the value of R as 0.083 rather than 0.082. There are few units which I want to discuss with you, that 1 Pascal is equal to 1 Newton per meter square, 1 bar is equal to 10 to the power minus 10 to the power 5 Pascal, 1 atmosphere is equal to 1.01325 bar, and that is why 1 atmosphere is equal to 1.01325 into 10 to the power 5 Pascal. Please remember these units because they are very important for the various calculations. And now let's move forward and solve few problems. For the equilibrium, 2NOCl gas at equilibrium gives us the 2NO gas plus Cl2. The value of the equilibrium constant Kc is given 3.75 to 10 to the power minus 6, and the temperature is given 1069 Kelvin. Calculate Kp for the reaction at this temperature. I have done the calculation of R for you, my dear students, that R is equal to 8.314 joule per Kelvin. So R is equal to 0.082 liter into atmosphere per mole Kelvin, which we can simply write it as R is equal to 0.083 liter into bar per mole per Kelvin. So this is what we are going to use. Now we know that Kp is equal to Kc into RT raised to delta N. For these reactions, if you look at the number of gaseous moles of products, it is 2 plus 1. So I have written 3, and for the number of gaseous moles in reactants is equal to 2, and therefore, my dear students, delta S is equal to, or delta N gas is equal to Np minus Nr, that is 3 minus 2, that is 1, and delta N gas is equal to 1. Now we are well aware that Kp is equal to Kc into RT raised to delta N. So here I have tried to calculate the R. R is equal to 0.082 into 1.01325, which ultimately leads us to the 0.083066. We will omit and we will just write 0.083. And that is what we write for Kc. We write 3.75 into 10 to the power minus 6. Here it is 0.083 and 1069. It is the temperature in Kelvin. And by doing all this calculation, we get this Kp is equal to 0.033. बच्चों अगर आपको कुछ समझ में नहीं आया तो आप लोग पूछ सकते हैं। प्लीज रिप्लाई थोड़ा जल्दी कीजिएगा। अगर समझ में आया है तो बोल दीजिए समझ में आया है, और कुछ पूछना है तो प्लीज
यस
पूछ
सर।
लीजिए। प्लीज रिप्लाई कीजिए डियर स्टूडेंट्स। हेलो।
समझ में आ गया। समझ में आ गया सर।
थैंक यू।
समझ में आ गया सर।
Thank you, beta. Thank you very much. Let's move forward. At 450 Kelvin, Kp, the value of Kp is 2.0 into 10 to the power 10 per bar. Per bar means 1 divided by bar, or you can say bar inverse. For the given reaction at equilibrium, we have this equation given that 2SO2 that reacts with O2 to gives 2SO3 gas. What is the Kc at this temperature? So they have given us Kp, we need to find out Kc. We are all aware that the formula is very simple, and the formula says that Kp is equal to Kc into RT raised to delta N. From the equation 2SO2 plus O2 that gives 2SO3, number of gaseous moles of product is equal to 2, and number of gaseous moles of reactant is equal to 2 plus 1. So 2 plus 1, that gives us 3. Therefore delta N gas is equal to Np minus Nr, that is 2 minus 3, which is minus 1. And Kp is equal to 2.0 into 10 to the power 10 bar inverse, because it is per bar, that is what it is written. So Kp is equal to Kc into RT raised to delta N. Here we have delta N is equal to minus 1, and therefore Kc is equal to Kp into RT raised to minus 1. This minus 1, if it goes up, or let us put the value, so it is 2.0 into 10 to the power 10 per bar, and 0.083 liter bar per mole per Kelvin to the power minus 1, and this 450 Kelvin even also having the minus 1 power. That means 2.0 into 10 to the power 10, 0.083 multiplied by 450. Now let us write the units. So liter into power minus 1, bar to the power minus 1, mole minus 1 into minus 1 become mole, Kelvin minus 1 into minus 1 become Kelvin plus 1, and this Kelvin to the power minus 1. So Kelvin plus 1, Kelvin minus 1 become 1. Same way here, if you see in the numerator we have per bar, bar inverse. Here even we have bar inverse. So what is left is this, that is mole per liter. So when we do the multiplication, we can write that, and this being minus 1, it goes up, it becomes plus 1. So we can write 2.0 into 10 to the power minus 10 multiplied by 0.083 multiplied by 450, and the unit is 1 divided by mole per liter. This mole per liter, we simply represent it as a molarity, and the answer is 7.41 into 10 to the power 11 per mole. So this is the answer we get. Please remember that in your textbook they have not mentioned these units, but it is very much necessary when you do the calculations, you show the units for the answers. This is a really a big problem with the textbook. So please do not follow, or please do not forget to calculate the unit for these answers whenever you do the calculations for your equilibrium. Now let's move forward and understand the next question. We have PCl5, PCl3 and Cl2 are at the equilibrium at 500 Kelvin and having the concentration 1.59 for PCl3, 1.59 molar for Cl2 and 1.41 molar for PCl5. We need to find out the Kc. So from the data we can say that, or we can write the reactions that PCl5 that gives PCl3 and Cl2. See here we have not mentioned them as a gas because we want to find out Kc. Therefore Kc we can write the concentration of PCl3 multiplied by the concentration of Cl2 divided by the concentration of PCl5. So we can just write Kc is equal to PCl3 multiplied by Cl2 divided by PCl5. Let us put all the values of the concentration which are given. For PCl3 they have given 1.5 molar. For Cl2 they have given 1.59 molar. So for PCl3 also they have given 1.59 and divided by 1.41 molar for PCl5. By solving this problem, we can find out 1.79 per molar. You can see that here only we have 1 molar, and here we have molar into molar. So it should not be per molar, my dear students, but the unit is going to be mole per liter. So it should be molar, not per molar. So this is how we can easily calculate the concentration or the Kc for these reactions. Please understand it well. Then we have the next question. The value of Kc is equal to 4.24 at 800 Kelvin for the reactions CO gas plus H2O gas, that gives CO2 gas plus H2 gas. Calculate the equilibrium concentration of CO2, H2 and CO, and oh, this is a complete page I have taken. Calculate the equilibrium concentration of CO, H2, CO and H2O at 800 Kelvin if only CO and H2 are present initially at concentration of 0.10 molar each. Now, my dear students, we want to understand this problem very well, so that let us pay enough attention and understand this. Now we are given the reaction CO gas plus H2O gas, that gives CO2 gas plus H2 gas. Now when we look at the initial concentration, initially only the reactants are present, and that is why the concentration of product is considered as a zero. Initially we have 0.1 molar of CO and 0.1 molar of H2O. Now what happens? Let X mole of each of the product be formed. So after some time, X molar of H2O and X molar of H2, X molar of CO2 and X molar of H2 is formed. Now you can see that if you see into the reactions, 1 mole of CO and 1 mole of H2O, when they react with each other, we get 1 mole of CO2 and 1 mole of H2 if the reaction goes for completion. So whatever the amount of CO and H2 are being used, the same amount of CO2 and H2 are being produced, and even the amount of CO2 and H2O produced are even same. So here we can see that X molar of CO2 and X molar of H2 are being produced, and that is why both these have been consumed, even X molar. So the final concentration at equilibrium, we have the concentration of CO as 0.1 molar minus X, because my X molar of CO has been used, so the final concentration is 0.1 minus X. Same way from H2O, X molar has been used, and that is why at equilibrium the concentration of H2O is 0.1 minus X molar. बच्चों, अगर आपको ये समझ में नहीं आया तो मैं फिर से एक्सप्लेन करता हूं, पर ये आपको समझ में आना बहुत जरूरी है. डू यू अंडरस्टैंड दिस? बच्चों,
नो
आपको
सर.
समझ में आया कि यहाँ पे मैंने 0.1 माइनस एक्स क्यों लिखा है?
नो सर, फिर से समझाइए प्लीज.
देखिए, मेरे पास अगर 100 रुपये है और मेरे दोस्त के पास 0 रुपये है, अगर 10 मिनट बाद और 1 आवर के बाद, आफ्टर 1 आवर, मेरे दोस्त के पास 50 रुपये आते हैं जो कि मैं देता हूं, मेरे देने से ही उसके पास आते हैं, तो मेरे पास कितने रुपये बचे होंगे? बताइए. हेलो.
50 रुपीज.
हाँ, क्यों, कैसे मिलेगा हमें आंसर? ये आंसर पाने के लिए क्या स्टेप लिखना होगा? यहाँ पे
100
हमें
माइनस
आंसर मिलता है 50,
50
पर वो क्या क्या मैथमेटिकल ऑपरेशन करने से 50 मिलेगा?
100 माइनस 50.
150.
हाँ, तो ये 100 यहाँ पे जो लिखा हुआ है 100, उसमें से मैं -50 करूंगा, तभी मुझे यहाँ पे 50 मिलेगा ना. तो यही है, देखिए ये दोनों रिएक्टेंट है, इन्हीं में से प्रोडक्ट बनना है. अब प्रोडक्ट बनता है X, तो ये कितना यूज हुआ होगा? बताइए, ये कितना यूज हुआ होगा? हेलो डियर स्टूडेंट्स, ये शुरुआत में हमारे पास 0.1 मोलर है, अभी इसमें से कुछ प्रोडक्ट XX बनता है. अगर प्रोडक्ट X मोलर बना है तो इसमें से कितना यूज हुआ होगा? हेलो, आपको बताना तो पड़ेगा ना. डियर स्टूडेंट्स,
Yes, sir.
कितना कितना यूज हुआ होगा? अगर ये मेरे पास शुरुआत में 0.1 था तब ये 0 थे, इसके पास शुरुआत में 0 पैसे थे, अब इसके पास 50 रुपये आ गए हैं जो कि मेरे में से ही दे के जाने वाला था मैं। तो अगर इसके पास लास्ट में 100 माइनस 50 बचते हैं, क्योंकि इसके पास 50 नए बन गए हैं, तो इधर यहाँ नए x बन गए हैं, तो इनके पास कितना बचा होगा? नहीं समझ में आ रहा है तो एटलीस्ट इतना तो बोलिए कि नहीं समझ में आ रहा है।
नहीं।
बोलिए प्लीज।
0.1 minus x.
तो ये समझ में आ रहा है? अब जो बोले थे वो बताएं कि ये 0.1 माइनस एक्स कैसे आ रहा है, वो समझ में आया क्या बच्चों?
Yes, sir.
ओके, फिर से एक बार देखिए, ये रिएक्टेंट शुरुआत में इतने थे, तब प्रोडक्ट कुछ भी नहीं थे। ये रिएक्टेंट यूज होने के बाद ही प्रोडक्ट बने हैं। प्रोडक्ट कितने बने हैं? तो एक्स मोलर बने हैं। तो रिएक्टेंट कितने यूज हुए होंगे? तो एक्स मोलर यूज हुए हैं। हमारे पास 0.1 थे, उसमें से अगर एक्स मोलर यूज हो गए हैं तो 0.1 माइनस एक्स लिखना पड़ेगा ना। तो यहाँ पे फाइनल जो इक्विलिब्रियम कॉन्सेंट्रेशन है वो 0.1 माइनस एक्स मोलर हो जाएगी दोनों की। Now at equilibrium we have got the concentration. So concentration of CO gas is 0.1 minus x molar. Concentration of H2O gas is 0.1 minus x molar. Concentration of CO is x molar and concentration of H2 is x molar. We know that Kc is equal to concentration of H2, that is concentration of products, that is concentration of H2 into concentration of CO2 divided by the concentration of CO and concentration of H2O. The concentration of H2 is x molar, so we have written x. Concentration of CO2 is even x molar, so we have written x. Concentration of CO is 0.1 minus x molar, so we have written 0.1 minus x. Concentration of H2O is even 0.1 minus x molar. Here both the time we have molar square, which does not give any units. And the value of Kc is given 4.24. Therefore, by putting the value of Kc is 4.24, we have x square divided by 0.1 minus x to the power whole square. That is x square into 0.1 square minus 2 into 0.1 into x plus x to the power a. This is like a square minus 2ab plus b square for the equation a minus b whole square. That is how we have formed. Now if we multiply this to 4.24 multiplied by this complete, so what I have written 4.20 multiplied by this bracket is equal to x square. Now if I multiply 4.24 with all these numbers, I get 0.0424 minus 0.8448 because I have multiplied 4.24 with 0.2, and 4.24 x square is equal to x square. If I take this side, then we can, or if I minus x square from both the side, I get 0.0424 minus 0.0848 x, 424 x square minus x square. So ultimately 424 x square minus x square is equal to 0. Is equal to 3.24 x square, and then I put this value and I have written 0.024x. So it is like ax square plus bx plus c is equal to 0. Here you can see that this equation is like ax square plus bax square, this is your a, bx, this is your b, and c is equal to 0. So here you can write that for this equation, a is equal to plus 3.24, b is equal to minus 0.844, and c is equal to 0.0424. We know that the root of this equation ax square plus bx plus c is nothing but your x is equal to